Good day, ladies and gentlemen. This is Sarel van Grennen, aka Mr. VG, and I'm on our second last video in this chapter, and this is specifically looking at exam type questions. Now, exam type questions, ladies and gentlemen, is where the pawpaw hits the fan. So, thank you for tuning and listening to me, Mr. VG, talking about straight lines. Let's dive into this question. So you go and try and do it yourself before you carry on with the rest of this video. When I look at a question like this, I love that you need to know your theory, grade 9. You need to know your theory. So I'm going to start off by just writing out the equation. It says give the gradient and the y-intercept of f. Remember, f of x represents y, okay? Remember that. That's just a very important little note. So is the y alone on its own self isolated? Yes, it is. So I can read off the m value and the c value, with the m value, of course, being the gradient and the c value being the y-intercept. I'm getting a spidey sense tingling in my bones. Why would they want to do it? Well, look at question C. Sketch the graph using the gradient intercept method. Woo! I love it. Okay? We love to ask questions like this where they bold on top of one another. Okay, remember that. That's how teachers ask it. Usually A follows to B, B follows to C. Not always, but a lot of the times, especially in your grade 11 and 12 curriculum. So when we look at question B, now they're asking you, would gx and that line have the same gradients? Whoa. That's 3y minus 3x plus 6 equal to 0. There's no way I can read off the gradient from that. So therefore, we've got to first write it in standard form. So we've got to get y alone. In other words, I'm going to add 3x on both sides and subtract 6 on both sides to leave me with 3y equal to 3x minus 6. Once I have this now, ladies and gentlemen, I can now divide both sides by 3, giving me y equal to x minus 2. I love it because now it is standard form. But I want to look at comparing it to gx. Now, gx is not exactly in standard form. I don't like it being 2 minus x. So I'm just going to kind of reshuffle it and write it as negative x plus 2 because there's a plus in front of the 2 there. Let's look at what we can read off. First of all, in the y equal to x minus 2, I can read off that the m value is 1. So the gradient's value is 1. In the gx, the m value is negative 1. So are the gradients the same? No, they're not. And there we've got our answer. So for us to compare gradients and intercepts, we must get it in standard form first. Now looking at sketching the graph f of x equal to 2x minus 1 using the gradient intercept method, first of all, the gradient is 2, which means it is 2 over 1. And therefore, I've got my rise and my run being plus 2 and plus 1. But I'm going to start at the y-intercept at negative 1. Remember that is going to be my starting point. So there. Then I'm going to rise 2 units, okay? So I'm going to rise 2 units. So let me just write it there, 2 units. And then I'm going to run 1 unit forward. And therefore, I have my equation or my graph sketched. But what did I forget to do, grade 9s? I forgot to write f of x equal to 2x minus 1. Okay? Bit squashed in there, but I must just write that for the examiner. Okay? Very important. Label your axes and write the equation on there. In our next video, which is going to be the last video in this series, we are going to look at some more equations, some more straight lines, where I'm going to ask you dual intercept and determining the equation of a straight line. But please tune into that last video and make sure you've got this covered. Ladies and gents, have a beautiful, amazing rest of your day. Salane Gatle. Bye-bye. Cheers.